All right, welcome to The Explainer. Today, we are stepping into the courtroom, but not just any court. We're talking about the statistical courtroom, a powerful way to put claims on trial and make huge decisions using data.
So let's kick things off with a problem that probably sounds pretty familiar. This isn't just for business. This kind of thinking applies anytime you need to test a claim, whether it's about a new health trend, a financial strategy, or just some life hack you saw online. Okay, to make this feel real, let's zoom in on a classic example from our source material. We're going to follow a purchase manager who's facing a really tough call about whether to buy a new, more expensive type of metal casting. So, you can see the manager is really in a tough spot here. On one side, he's got the promise of a better product, but on the other, there's the very real risk of just wasting a ton of money. He can't afford to just guess. He needs a system, a formal way to figure out if this supplier's claim is the real deal or just a bunch of hot air.
And that is where he turns to a formal procedure called hypothesis testing. This, my friends, is our ticket into the statistical courtroom. It's a method designed specifically for putting claims on trial using data as the evidence.
Now, this whole courtroom analogy, it's not just a cute gimmick. It's actually the perfect way to understand how this all works. So let's get into it. Court is now in session, and the new supplier's claim is on the stand. First things first, in any trial, you need a charge, right? In statistics, that's called a hypothesis. It's just a formal statement about the entire population. In this case, all the castings the new supplier could ever make. And the statement we're testing is simple. Are their castings actually harder? Now, every good courtroom drama has two opposing sides, right? You've got the defense and the prosecution. And it's exactly the same here. The null hypothesis, or H0, plays the role of the defendant. It's the status quo, the assumption that nothing has changed. It's innocent until proven guilty. And challenging it is the alternative hypothesis, the prosecution, which is making the new bold claim. So for our manager, what's the default? The innocent position. It's that the new supplier's castings are no different than the old ones. That's our null hypothesis. The claim that they are actually better, that's the alternative. And this is so important. Just like in court, the burden of proof is on the new claim. It has to prove itself. Now, this is absolutely crucial. You can't just walk into a courtroom and start throwing evidence around. You have to agree on the rules first. Specifically, how much evidence is enough for a conviction, and you have to decide this before you see a single piece of data.
Look, because we're only testing a sample of castings, not every single one they'll ever make, we have to admit something up front. Our verdict might not be perfect. We could get it wrong. And as you can see here, there are exactly two ways that can happen, alongside two ways we get it right.
Let's break these errors down. A type 1 error is like a wrongful conviction. You switch to the more expensive supplier, and it turns out they weren't any better. Ouch. That's a direct financial loss. A type 2 error is like letting the guilty go free. You stick with your old supplier and miss out on a real improvement. For our manager, that type 1 error is the big one to avoid. It costs cold, hard cash.
So how do we put a leash on that risk? Well, we set a formal standard of proof. It's called the significance level, or alpha. This is our line in the sand. It's the maximum risk of a wrongful conviction that we are willing to accept. It's basically our version of beyond a reasonable doubt.
So what's a typical number for alpha? Well, a really common choice you'll see pretty much everywhere is 0.05, or 5%. By setting this, we're saying we will only tolerate a 5% chance of making that costly type 1 error, of concluding the new supplier is better when they actually aren't. Okay, let's recap. The rules are set, the standard of proof has been defined. Now, it's time to bring in the evidence. Let's see what the data from the sample castings actually says. And here it is. The manager tests a sample of 100 new castings and finds their average hardness is 20.5. Now remember, the old average was 20. So on the surface, this looks pretty good for the new supplier's claim. But is it enough? But wait a second. Is that 0.5 difference really meaningful? Or is it possible that we just got lucky? Maybe this particular sample of 100 castings just happened to be a bit harder by pure random chance. This is the million-dollar question of the trial, and the answer comes from something called the p-value. Okay, this is where the p-value comes in. Now, the official definition can sound a little academic. The probability of observing a sample statistic as extreme as... Yeah, but stick with me because what it's doing is actually super intuitive once you translate it. Here it is in plain English. The p-value asks, let's assume for a second the new castings are not actually better. What are the chances we would get a result this good just by dumb luck? A really, really low p-value means, whoa, this result is super surprising. It's very unlikely it was just luck. All right, this is it. The climax of the trial. We take our evidence, the p-value, and we hold it up against that standard of proof we set way back at the beginning, our alpha. And the rule for the verdict is incredibly simple. It's a straight-up comparison. If your p-value, the surprise factor of your evidence, is smaller than your alpha, your standard of proof, then boom, the evidence is declared statistically significant. You've met the burden of proof, and you can reject the status quo. So, back to our manager. The p-value calculated from his sample data was 0.001. That means there was only a 0.1% chance of seeing castings this hard if they were truly no better than the old ones. Since 0.1% is way, way smaller than the 5% standard of proof we set, the verdict is in. Reject the null. The evidence is strong enough to conclude the new supplier is the real deal. So let's just step back for a second. What we just walked through, this whole courtroom drama, it's really this repeatable 5-step framework. You state the competing claims, you set your standard of proof, you define the rule for your decision, and only then do you look at the data and make the call. This is the process you can use to bring real rigor to your own decision. And once you get this framework, it's honestly like having a superpower. It moves you beyond just gut feelings and anecdotes. So think about all the claims you hear every single day about your health, your finances, productivity hacks. Now that you have the keys to the statistical courtroom, what common belief would you want to put on trial?